Welcome. The class of today is about the technical analysis general consideration. This is the first class of a more comprehensive module in which we will explore different elements and different phases of the so-called technical analysis. As we will see during these classes, technical analysis is related to the fact that the investment should be translated into acquisition of technology and installation of technical facilities. So several ideas that we are familiar with already, like production program, like technological choices, like the exploration of technical and technological alternatives, will rise up again and we will deepen the related contents. Let's start with the outline of today. We will ask ourselves what is and what includes the technical analysis. Lately, we will define the scope and extent of the technical analysis. So, we will recall some ideas we are familiar with already, and we will deepen them and add some additional contents. The third element, and the last one, is when and in which phases of the investment project the analysis is required. So let's start with the first element. What is and what includes the technical analysis? Technical analysis is necessary if the project is approved for investment. Detailed engineering is required. So the starting assumption is the project is approved, and then we have to engineer and design the different phases. The second consideration about technical analysis is that an implementation plan must be developed and the actual construction and installation managed. So technical analysis, as we can see so far, is made of two main elements: design, once the project is approved, and the definition of the different phases and the management of everything that we're going to build and install. To be more specific and to deepen in a more effective way what the technical analysis could be, we should answer different questions. So the engineering and technical analysis answer the following questions. What is the most appropriate technology? So as we will see, next class, technology could be defined in a different way, and in order to choose the most appropriate technology, we have to accept the hypothesis that we might be exposed to different technological alternatives, which means that in order to carry out the same activities, we might refer to different possible workable solutions. The second question is related to the fact that required materials and other inputs could be reliable and available. So, are required materials and other inputs reliably available? Further, is the available labor pool adequate for the project? If not, is it possible to train workers as required? So the idea is that the technical analysis, as we'll see, is not just about technology, it's about human resources as well. These kind of human resources, they could be available on the premises or they should be trained in a proper way. Where should the plant be located? So as we will see, when it comes to location, it's not about the exploitation of physical resources, but it's about the general and whole amount of resources which are needed for the investment. So location can be determined by the availability of natural resources as well as their utilities, as well as the availability of workforce or adequate for workforce for the activities that we have to carry out. Further, what is the implementation plan and how much time is required? So the idea is that the implementation is driven and controlled by a plan, and the implementation of such phases which are designed in the implementation plan should require some time. So we have a timeline which is fixing the delivery time for the implementation phases, and then we have the overall time related to the overall investment. What are the costs of investment, implementation, and operation? This is another important question. It's not just the cost of investment, it's not just the so-called sunk costs, which are relevant for the technical analysis, but we should consider also the implementation and operational costs. So, considering these questions, the technical analysis is the answer to all these questions in a structured way, which means that we have to design the activities on the premises. Ex ante, we have to define what are the intermediate goals that we have to achieve and what are the resources related to such intermediate goals. Select the most favorable process for converting capital, facilities, and resources into marketable goods and services. So, this is the mission of the technical analysis. It's about the selection of processes, which implies that we have alternatives at our availability, for converting capital, facilities, and resources into marketable goods and services. This consideration explains and shows and enlightens furtherly why we have to consider both the financial aspects and the market-related aspects in order to deliver a general assessment of an investment project. Further, we have to consider the environment in which the activities are to take place. And as you will see, it's not just the competitive environment, which is made of the firm and its competitors, but the very last class of this module is going to deal with the eco-sustainability of our investment. So we will deal with natural sustainability, we will deal with green management as well. That's why the idea of location and environment is so crucial to consider within the technical analysis. Third, through the technical analysis, we have to determine the capital and operating costs associated with the plan. So again, it's not just activity scheduling, it's not just the utilization of the Gantt or the PERT solutions, as we will see, but it's also the economic evaluation of each alternative. It's also the analysis of the economic impact of every choice of the company. Then, the technical analysis, it's summarized in a comprehensive technical report. So, prepare a comprehensive technical report. It's another crucial aspect of the technical analysis. As we've seen during our previous classes with market and marketing, for example, all the activities should be summarized in a report. Same with the technical analysis, all the considerations that we make should be summarized in a technical report. So this is the general consideration related to the exigency of technical analysis. To be a little bit more specific, if we try to answer to the question, why the technical analysis? We have three main answers. First one, consider technical alternatives. If we didn't have any alternatives, technical analysis would be way more simple to make. Second, avoid pitfalls of technology offers. This is very important, and this is a very crucial point since it's often neglected by firms. In order to avoid pitfalls, companies should be very aware of the different technology alternatives or technology offers. So, being aware of the strengths and weaknesses of each alternative could help companies avoid the threats, the pitfalls in the choice of a specific alternative and or in the implementation of a specific alternative. Third, avoid consequences of technological weaknesses. So, technology is a competitive weapon for the companies. So, if the project is choosing the wrong technology, a weak technology, then the overall competitive advantage of the company could be compromised. Just to give you an idea of how to design the project, the technical design project could be pictured this way. We start from the SAIL program, as we've seen during our last class. That could be considered the input for the production plan. Then we have production program and schedule, plant capacity, which means that once we have programmed and scheduled the activities related to production, we can deal with the definition of the plant capacity if we have to install it, or if the plant is already existing, we have to define a policy for the exploitation of such capacity. Then we have technology selection, and here we have this element which is EIA, Environmental Impact Analysis. So, as I was telling you a few minutes ago, we will end up with the consideration of the natural environment as well, with the consideration of the impact of our investment upon the natural environment. The arrow, which is depicted in this process, then leads to the equipment selection. So, we have a general choice which is related to technology selection, and then we have a specific choice which is related to the equipment selection. So, for example, here we might have an electricity-based solution, and here we have a specific machinery which is related to this kind of technology. We might have a green technology as an option here, and we might have a green facility here which is going to be installed. Then we have production process engineering. So it's not just about the selection of a specific alternative related to technology, but it's also the definition of the production processes. Once the processes have been designed, it's possible to proceed to planning production processes. So we switch from engineering, which is the design, to planning, which is the definition again of actions and times related to the engineered plan. And then we have location and site, preliminary facilities layout. Once we have engineered the activities and planned the activities themselves, then we have to work on the layout, the physical layout of facilities. Once the facilities have been installed, then we have to consider the manpower, plant organization, and overhead costs. So just to recall you the idea, the overhead costs are those kind of indirect costs that should be considered as a part of the investment itself, although they are related to the whole company and not just the single project. And then we have the last phases, which is the implementation scheduling. So once we have designed the whole process, then we have to schedule the different alternatives. So as you can see, we start again from the sales program and we end with implementation scheduling. This is the overall process that we're going to explore through these classes on the technical analysis. So to focus a little bit our attention on our general aspects of technical analysis, let's consider the scope and extent of the technical analysis. Let's start with the extent of technical analysis. The extent should be sufficiently extensive to provide reliable information concerning project feasibility. So the extension of the analysis should cover several aspects related to the project actual implementation. The extent should be sufficiently detailed to obtain desirable accuracy in the project cost estimates. So it's not just the spread of the analysis, it's about the depth of the analysis as well. So it should be comprehensive and accurate in both ways. When it comes to the scope of technical analysis, we have different elements that we have to define. We have different elements that we have to deal with. In details, we have the product design. We have the definition of technology. We have to consider aspects related to the environment, both competitive and physical and natural environment. We have to define materials and other inputs. So it's crucial to define the supply exigencies of our installation. Then we have to define, again, the organization, so roles, responsibilities, and other operational mechanisms like procedures or routines, for example. Human resources, both in quantitative and qualitative way. Facilities requirements in terms of location, utilities, in terms of services, and so on. Infrastructures surrounding the facilities. This could be physical infrastructures like highways, for example, or social infrastructures like the existence of additional services provided by the community, the surrounding general community, like schools for employees, children, for example. Location, so the specific location. We will see that the choice of location is particularly important since a wrong location could compromise the feasibility or the profitability of our investment. The project implementation aspects, which means that the project, once the project is engineered or designed, then it requires a specific project management governance. And last but not least, we have the costs to be considered for the project implementation. Specifically, these costs could be directly related to the investment or indirectly related to the investment or generally related to the whole company. So far we've seen what are the scope and extent of technical analysis. And we have all these kind of prescriptions to follow, and we have all these kind of warnings related to the different elements that we should take in consideration, from the product design to the costs, passing by human resources, infrastructures, and so on. What is very important to point out is that the inadequate technical analysis could compromise in a very serious way our investment. So if we analyze the consequences of an inadequate technical analysis, we have the approval of ill-grounded project. An ill-grounded project is a project which is biased from its premises. So it's grounded on a hill, which is a loss of invested resources. So if something is wrong in the technology we choose, we have a resource leakage in the process, which means that we're basically wasting resources. The second alternative is when we have the approving a viable project without complete and competent technical analysis. So the project itself could be self-standing or viable, but the analysis is inaccurate or is incomplete. In such a situation, it's quite likely that the company is facing delays in the project implementation and the profitability lower than expected. So we have, as a consequence of a lack of completion or competency in the technical analysis, we have a lower income or higher costs related to both of the wrong or ineffective coordination of activities, and in turn we have a lower profit than expected. The third analysis is related to rejecting a viable project due to inadequate technical analysis. So we started from the acceptance of a wrong project, and a third scenario is the opposite one, is the rejection of a right or a promising project due to the lack of technical analysis. This is a loss of anticipated profits, development opportunities. So if the technical analysis is wrong on the premises and we renounce to a profitable project, we're losing money on the premises. We're losing opportunities for investing our money in a profitable way. So basically we have these three consequences of an inadequate technical analysis. We accept the wrong project, we refuse the right project, or we manage the right project in a wrong way, in a more expensive way. When it comes to the implementation of the technical analysis, we deal with when and in which phases of the investment project. So far, we have considered the investment project as a process made of different phases, made of different stages. So let's have a closer look on when and in which phases of such a process technical analysis should take place. So technical analysis is related to engineering analysis. Engineering analysis is made of planning phase, investment phase, operating phase, and eventually decommissioning. So this is the cycle accompanying the engineering analysis. And the technical analysis is relevant in each of these phases. If we consider the planning phase, technical analysis and design during the planning phase, we are encountering basically two main elements, the product analysis and the process design. So let's recall some ideas we should be familiar with so far. The technical analysis as the sales program as an input. If the sales program is an input, that means that the marketing strategy has been already defined. And as we've seen, one of the 5 elements of the marketing analysis, marketing strategy, is the product. So the concept of the product has been defined, and now we have to operationalize this idea. So the technical analysis interferes, or let's say supports the planning phase, since we have the product analysis and the design of the productive process by which this good is manufactured, or by which this intended service is delivered. Then we have the plant design. So if we consider manufacturing, then we have to design the actual shape and the actual layout of the plant. Then we have to draw the related organization structure, which means how these activities are going to be structured in terms of role and responsibilities. And then we have the implementation and decommissioning plans, as well as the project cost estimates. So the technical analysis encounters the planning phase in all these steps. Of course, the intensity of the requirements of technical analysis during the planning phase is different in each of these steps according to the general strategy in which the project investment is going to be hosted, and also considering the specific choices that the company has made regarding technology and regarding the different specific characteristics of the plants, the process, the products, and so on. Another important link to be analyzed is the one connecting technical analysis, design, and supervision during the investment phase. So we have the planning phase, and then we have the investment phase. During such a phase, again, we have to deal with different steps in which technical analysis could be relevant. The first one is the detailed engineering designs. Procurement of materials and equipment for construction and plan. So, as you can see, we are deepening the level of analysis by finding more and more specific elements. Construction and installation supervision. This is very important, and this is also quite a neglected phase in many cases. It's not just, investment is not just the material construction of something. It's also about the supervision and the installation of the capacity. And supervision is crucial because sometimes it's made by the top management of a company, sometimes it's made by external consultants. In both cases, it could generate additional costs if it's made in a non-sufficient way. Then we have maintenance and quality control plans. So it's not just about the installation again, it's about maintenance and quality control as well. It's about recruitment and training management and operating personnel. So it's not just about technology, as we've seen already, it's about the workforce, which is interacting with the technology itself. Supervision of plant commissioning. So, the commissioning phase is crucial in the investment phase. And as we've seen during the planning phase, commissioning and decommissioning are two important phases in our project investment. They both should be monitored, both should be estimated in terms of costs and risks for the project itself. So, technical analysis is interacting with the planning phase, it's interacting with the investment phase, as well as it's interacting with the production phase. So, technical activities during the production phase. Training, manufacturing, personnel, it's the first one. So, the general idea is that once the facility has been installed, once the construction has been finished, then we have to operationalize our activities. So, we should start from training the manufacturing personnel if it's not educated, skilled, or competent enough. Second element, production supervision. So any kind of production, even the most automated one, requires supervision. Supervision could be made by humans or by other technologies supporting other humans. As a matter of fact, the technical analysis should include this element of supervision in the estimates which is producing. Process refinement. So once we have completed the engineering of the activities, we have a draft of the production processes. Those processes could be improved because people are exposed to learning experiences effects. So the more frequently they're exposed to some activities, the higher is the gain in terms of learning. And the learning effects in the medium and long range are able to produce the conditions for obtaining the same outputs with, in a more efficient way by employing less inputs. Which means that by doing the same thing, people are able to learn, and if they're able to learn, it's possible to refine the production processes. It's possible to improve, it's possible to rationalize the production processes. Implementation of maintenance program. So, maintenance is crucial in investment phase, as we've seen, but it's not just the estimate of the cost of maintenance, it should be implemented as well. And the implementation of maintenance program is another very important element for the technical analysis of the production phase. Maintenance could be ordinary or extraordinary. By definition, the ordinary maintenance is the one which is planned, scheduled, and could be more monitored in a more effective way. Whereas the extraordinary maintenance, by definition, is related to unexpected events. One common mistake that is very diffuse about investment projects is the fact that sometimes it's easy to schedule and estimate the cost of the ordinary maintenance. Sometimes extraordinary maintenance is neglected. What is very important to understand is that it's not just related to events of nature, but the risk related to extraordinary maintenance could be insured as well. So both from a technical and from an economic point of view, an evaluation point of view, both ordinary and extraordinary maintenance should be considered the same way. Quality control implementation. This is very important also. When it comes to the production phase, quality it's related to the marketing strategy and to the general strategy of the project. So the level of expected quality related to products and services is closely related to the concept of products and services that we have developed during the marketing strategy activities. So quality control should be consistent with the technical requirements and the technical features of the product itself. So the implementation is crucial from a technical point of view too. The last interaction we're exploring for today is between the technical activities during the decommissioning phase. So sometimes, as I was mentioning before, the investment projects are very detailed in describing and planning and scheduling everything which has to do with the commissioning phase. And they are very dangerously neglecting the decommissioning phase. So the decommissioning phase is about the supervision of the project dismantling. So if we are planning to build up a facility and the operational expected time of such a facility is, for example, 20 years, we should not only plan the activities for the first 20 years of operations plus the investment and installation phase for realizing the plan, which could be 2 years. So in such a case we have 12 years, 22 years of of time extent, 2 years for the investment and 20 years for the operations. But we should add to these 22 years another additional 1 year, for example, for the decommissioning phase. So, since the project needs to be dismantled, we should include the supervision of project dismantling as well, both in the time schedule and in the cost estimates. The second element is about arranging for disposal of materials. This is another crucial element. Since during the investment phase, we could deal with dangerous goods or raw materials like radioactive or toxic wastes. The building itself could be made of perishable or dangerous elements in the long range. If you consider the utilization of asbestos during the 80s all over the world, then it's quite clear to understand how delicate the disposal of such materials could be during the dismantling phase. Third, the site cleanup. So, the idea is that if the investment is made in a greenfield, according to a greenfield approach, the company is investing in an area where there was not industrial activity. When the company itself is dismantling the investment, then the local conditions should be representated the way they were before the investment itself. The same logic occurs also for the so-called brownfield investment. So, as we've seen since the beginning, a brownfield investment is made when a company is investing in an area where some industrial activities were already present, but probably from a different perspective or coming from a different industry. In the very same case, whatever activity should be decommissioned in the way that the site should be cleaned up. And so the conditions from an environmental, from an industrial point of view should be represented if the project has a time deadline and it's expected to finish in a specific amount of time. So, today we have dealt with the general considerations about the technical analysis. We have explored the scope and extent of the analysis as well as the interactions with the different phases of the investment project that we are familiar with from the previous classes. You can find further information and more details on our website. Thank you for your attention.